Utme candidate, this is physics past question. If you are given this question, how will you solve it? Let's quickly solve. It says, let me read the question first. It says, calculate the mass of ice that would melt when 2 kilograms of copper is quickly transferred from boiling water, okay, to a block of ice without heat loss. All right. So we are given the specific heat capacity of copper to be 400 joules per kilogram per Kelvin, and the latent heat of fusion of ice. This should be specific latent heat of fusion of ice. Is what? 3.3 times 10 raised to the power 5. 10 raised to the power 5. This is 10 raised to the power 5, not 105. 10 raised to the power 5 joules per kilogram. So let's solve. Solution. This is a very simple question, but you have to apply the knowledge that you know to be able to get it well. So I feel I will need more space. So let's draw this. So I always say this, that if you want to know a question, you want to get a question quickly, and you are sure that you are getting that you are going to get that question correctly, you need to know where the question is coming from. So you know that this question is coming from measurement of heat, or heat measurement, where we have specific heat capacity, quantity of heat, specific latent heat of fusion, and all of those things. So now, this now, if you see in your textbook, you see things like how to calculate specific heat capacity, or how to get specific heat capacity of different of substances, or the general way of getting specific heat capacity of substances. So there's what we call the electrical method, where the current is supplying heat to the substance. You get? So current will be the one that is supplying it. The other substance will be the one that is gaining it. So there's also what we call methods of mixtures, where there is a substance that has high temperature, that has higher heat energy, that is transferring what heat to another one of lower heat energy. I hope this is clear. So that's method of mixtures. And this one is method of mixtures, where we have one transferring heat to another. One that has higher heat energy is transferring heat to another one. So you just need to decipher the one that is supplying heat and the one that is gaining heat. If you can know this, you will get any parameters you are asked to look for. Now, like I said, this is methods of mixture. There's one that is at higher heat, that is supplying one to, and that is supplying heat energy to another one at lower heat energy, or lower heat. Anyone. So let's read the question again. It says, calculate the mass of ice that would melt when 2 kilograms, that means there's something that is melting that ice, when 2 kilograms of copper is quickly transferred from boiling water to a block of ice without heat loss. That means we assume that there's heat is not lost to the surroundings. You guys get? So now, looking at this, you know that what is supplying heat is the copper, because they said we take 2 kilograms of copper. This is, let me say, assume that this is 2 kilograms of copper. This copper now, 2 kilograms. We take this from boiling water. You know that the copper will be very hot, and because we are taking it from boiling water, water boils at 100 degrees Celsius. So this one will be at 100 degrees Celsius. So we now take this, and we now what? We transfer it to, this is a block of ice. Yeah, we now put this, we transfer it to a block of ice, probably in a container. So we are looking for the mass of this ice that will melt completely, that will melt, the mass of this ice that will melt when this copper is transferred, that we took this copper from boiling water, we transfer it to this. We are looking for the mass of the ice that will melt when this is transferred to this. Simple. So from here, you know that the one that is supplying it is the copper, and the one that is gaining heat is what? The heat energy is what? The highs. So we can write that heat supplied or gained, except supply or gain, or loss by the copper. Copper is C. Let me just write that C equals heat gained by ice. Let me clean this. So heat loss by copper or heat supplied. If you are supplying something, you are losing it. So heat supplied by the copper equals heat gained by ice. So heat supplied, that's quantity of heat supplied. You know that is MC, change in temperature. That change in temperature is, let me just say delta T. This change in temperature is final temperature. Change in temperature. Just now, change in temperature is initial temperature of copper minus, or let me just use T. Initial temperature of copper, minus the final temperature of the mixture. Initial temperature of copper minus final temperature of the mixture. So this is MC change in theta equals um change in temperature equals heat gained by ice. Now we need to be very careful. Let me read the question again. Calculate the mass of ice that would melt. Okay, ice melting. Remember that the ice melted, and remember that melting occurs as at a particular or a constant temperature. Here, it is ice. Ice is water in solid form. So ice melts at 0 degrees Celsius, right? Ice melts at 0 degrees Celsius. So ice melts at a constant temperature. There is no raise in temperature when ice melts. It's just that when ice melts, the temperature remains, the heat that is absorbed is used to change it to a liquid form without a change in temperature. I don't know if you guys understand this. You will know that what the heat gained by the ice is going to be the latent heat of fusion, which is ml. Remember, the definition for latent heat of fusion is the heat required to a solid without melt a solid, basically. So let me expand the definition. It's the heat that is required to change a substance from solid form to a liquid form without a change in temperature, without raising the temperature of the substance. So let me now bring it down to melting. Now it is the heat required to melt a substance. So melting occurs at a particular temperature. Melting is just when you change a solid form to a liquid form without increasing the temperature, without the temperature being increased. So here the heat gained by ice will be latent heat of fusion, which is ml. Remember, I corrected something here. This should be specific latent heat of fusion, not latent heat. This is specific latent heat of fusion. So this L represents specific latent heat of fusion. This L, small l. So here we have the mass of copper to be what? Mass of copper to be 2 kilogram, right? The specific heat capacity of copper, this is specific capacity is what? 400 joules per kilogram per kilogram per Kelvin, right? So specific latent heat of fusion, okay, sorry, we have change of temperature, change equals, I said it here, that is final temperature, initial temperature of copper minus final temperature of the mixture. Initial temperature of copper is 0 degree Celsius because it's from boiling water. So water boils at 100 degrees Celsius, 100 degrees Celsius. And the final temperature of the mixture will be 0 degree Celsius because there's no change of temperature really. The ice absorbed all the heat just to melt it. We are looking for the mass that will absorb all the heat just to melt the ice, not to raise its temperature. So the final temperature of the mixture of both the ice, which is already in its soaking form, and the copper will be 0 degrees Celsius. So this is the final temperature. So the mass of ice, that's what we are looking for. And then the specific latent heat of ice, fusion of ice, is 3.3 times 10 raised to power 5. So let's now put this here. So we have mass to be what? 2 kilogram times specific heat capacity of copper 400 times the temperature change is 100 minus 0, which we have as 100, equals, we are looking for mass of ice times L, which is 3.3. That's this 3.3 times 10 to the power 5. So this we have, this is going to be 1, 2, 3, 4. This is 8,000, right? Equals 3.3 times 10 to the power 5 mass of ice. So divide both side by 3.3 times 10 to the power 5. I don't want to use calculator, so I'll use another format. So here we can turn this to standard form. This becomes 10 raised to the power 4. 8 times 10 raised to the power 4. 1. See, it's 1, 2, 3, 4. No, this is 80,000. Sorry. 1, 2, 3, 4. 10 raised to the power 4. 8 times 10 raised to the power 4. 3.3 times 10 raised to the power 5 equals mi. So we can convert this to 10 raised to the power 4. So we we cut it. We cancel it. 10 raised to the power 4 over 33. This becomes 33 times 10 raised to the power 4. This is also the same thing as this, but different expression. So this cancel this. So we have 8 times 1 mi equals 8 over 33 times 1, 33 kilogram. Simple. This is A. This, you actually have to learn, solve a lot of questions on this. So that when they give you questions, you know that this is what you're applying, this is what you're applying. This is like a whole course on its own. You guys get, but I hope with this explanation, you guys will be able to solve some questions. Thank you for listening. Thank you for watching. Like, subscribe, share the video.